I want to introduce you to the concept of radians, but before I do, we need to do a little background. The overall concept here is angles and angle measure. We measure angles in degrees, and then the measure of an angle is in radians. So we'll start off with first the idea of x and y axis with a circle centered at the origin, and a ray that goes out at 0 degrees, and another ray that goes out at some other location. And we'll define these guys. We're going to define the ray that starts over here, and by the way, this is known as 0 degrees on the coordinate plane, as the initial side. And we're going to define the ray that goes up here as the terminal or the final side of our angle. And what we do is we measure the angle as we go from the initial side to the terminal side. In this case, our angle is 30 degrees. And if I want to, I can go ahead and I can stretch that angle out, and we can see, let me do it a little more slowly. So we can go ahead and we can either make that angle smaller or we can make that angle bigger. But the idea of an angle is something that measures how much we turn as we go from the initial side to the terminal side, like such. So with this idea in mind, we will call the measure of an angle the amount that you turn when you go from the initial side to the terminal side. That we would call that an angle, and we'll measure that in degrees. And then we also have, but we have something else that's related to that. When we talk about the degrees of this angle here, where the two rays start in the center of the circle or at the origin, we call this the degrees here the central angle. And one of the things we're interested in is what is the measure of the arc length associated with the central angle. And so let's go ahead and write some notes on that. If we want to talk about the measure of the arc length that's associated with the central angle in degrees, it'd be nice if we had some sort of unit to refer to. Like when we want to talk about distance, we talk about inches or centimeters. When we want to talk about weight, we talk about ounces or pounds or grams or kilograms. So it'd be kind of nice if we had a unit of measurement for the arc length. After all, we have a unit of measurement for how much we turn to get from the initial side to the terminal side. We have that's called degrees. It'd be nice if we had a name for this, and it turns out we do. The name that we have for this arc length is called radians. And let's take a look and see where the name radian came from and exactly what a radian is. A radian is a pretty cool concept. It sounds a little bit like it's unfamiliar to us, but it's actually something that's familiar to you. If you know what a radius is in a circle, then you know what a radian is. A radian is just the measure along the outside of the circle of one radius. Let's take a look. We'll see with this animation. If I go ahead and I stretch, if I pull that radius, that blue line, from the actual radius to the edge of the circle, what ends up happening is this distance, this arc length, is known as 1 radian. And down here we can see when I pull that radius up onto the circle, I've gone a distance of 1 radian, and we can see that right here. Now, if I keep pulling, I can pull, see this red line? It's another radius. I'm going to go ahead and pull that guy onto the circle as well. And now that I have, the angle here is 2 radians, or I should say the measure of the arc is now 2 radians. And then let's go a little bit further. Because unfortunately right now we don't know how many degrees 2 radians is. But it turns out that at a certain point the number of radians matches up with a very familiar and well-known degree. So I'm going to keep going. I'm going to pull another radius. I'm going to pull that green radius onto the edge of the circle. And you'll see that now that I've done it, we've gone 3 radians, and we've almost gone 180 degrees. When we go from here, 0, all the way around to here, this is called 180 degrees. If we go a bit more, we'll go exactly 180 degrees. And it turns out when we go that little bit more, we've gone about 3.14 radians, or actually we've gone exactly we've gone exactly pi radians. And so what happens is when you go pi radians around a circle, you have gone 180 degrees. So it turns out that this is a real convenient way to figure out how to convert between radians and degrees. 180 degrees is pi radians, and pi radians is 180 degrees. We can go a little bit further. We can keep pulling radii onto the circle, and as we do, eventually we get all the way around to almost 360 degrees. Again, once we've gone 6 full radians, we almost hit 6 radii. We've almost gone all the way around. Again, if you multiply pi times 2, you get about 6.28. So if we go 6.28, or exactly 2 pi radians around the edge of the circle, then all of a sudden you get 360 degrees. So just wanted to point that out. Now, one of the neat reasons why we like the idea of measuring things in radians is because of this. It doesn't matter what the size of the radius is. We can take any circle and we can go 180 degrees around, and when we do, we have always gone pi radians. It does not matter what the radius is. In this particular circle, the radius is 1. But if I change the radius of the circle to 1.2 or 1.3, I can still see that my angle is still about pi radians for 180 degrees. And likewise, if I make the radius smaller than 1, I can still see that if I go halfway around the circle, I'm still 180 degrees and it's still pi radians. So radians are a way to measure distance around the edge of the circle. 1 radian is 1 radius. That's true for any circle of any radius. And if I go pi radians around any circle, I have gone halfway around, or 180 degrees.